Hi, welcome to another lecture on simple machines. Today we'll be talking about efficiency and work. At the end of this lesson, students should be able to define work output, work input, define a machine's efficiency, explain why in reality a machine's efficiency is always less than 100%. Effort and load work. The work effort of a machine or work input of a machine is a product of the force applied at the effort and the distance the effort moves parallel to its force's line of action. The work effort is equal to the effort E times the distance moved by the effort dE. The load work or work output is a product of the force of the load that must be overcome and the distance the load is moved parallel to its force's line of action. So workload is equal to load L times the distance moved by the load dL. For an ideal machine, all work input at its effort becomes useful at its output. What does that mean? It means all work, all the energy put into the machine is used at the end and no one is wasted. Meaning implying that for an ideal machine, work effort must be equal to workload. Okay, let's try now to explain the effort work and the load work using this diagram that you see on your screen. From the previous lesson on work that we did in class, we saw that work is equal to force times the distance. Right. Now, let's use this from this relationship. We have to come out with the relationship for what? Work effort and workload. So now work effort means the work the work done by the effort. So equal to the force, which the force now in this case now is the effort times the distance is the distance moved by that effort. Which from this diagram, look, it will be from A to B, but this time moved by effort, like that. So now, in bracket, let's just put AB, that you understand. It's AB from year to year. Now, if you use that diagram, you'll see that the calculation will be 200 newtons times 2 meters, which your answer gives you 400. And 400, you cannot add that answer because work has a unit, which is joules. Right. Now, what is the work done by the load? So the work done by load, we call it workload. The workload will be equal to now the load times the distance moved by the load. And in bracket, we'll put from this is a load, and the distance moved by load from B to C. In bracket, put B, C. So we equal to, now we have the load is 100 newtons times 4 meters, which will give you 400 what? Joules. So that's the work done by the load and the work done by the effort. So that's how you should calculate the work effort and the workload. Hope it's understood. Then now, knowing the workload, knowing the work effort of every machine will help us to calculate the efficiency of that machine. So what now is the efficiency of a machine? Efficiency. The efficiency of a simple machine is a percent ratio of its workload divided by its work effort. So efficiency is equal to the workload, which is WL, divided by work effort, which is WE, that is 100%. It is a scalar quantity. It has no units. In practice, no machine is ideal, meaning that no machine has an efficiency of 100%. This is because some amount of input effort work is always lost as heat due to friction and other forms of energy. A machine that experiences very little loss of work effort or input energy to other forms is considered to be efficient. Now, let's see how to calculate efficiency of a machine. The efficiency of a machine can also be defined as the ratio of its mechanical advantage to its velocity ratio. Now, what do we mean? And how is that possible? We said efficiency, what we have seen earlier, is that it's equal to the workload of a work effort times 100%. Now, the workload, as we saw earlier, is load times the distance moved by the load. And the work effort is the effort times the distance moved by the effort. Now, we can separate these two, this load times distance moved by load and effort times distance moved by effort into two separate quantities. Now we see that we take L divided by capital A times distance moved by load divided by distance moved by effort. So if you see that, you look at this, is what we have done. We have seen earlier in previous videos. Now, load over effort is equal to the mechanical advantage. And distance moved by load over distance moved by effort is similar to the velocity ratio formula, which is distance moved by effort divided by distance moved by load. And you see that these two, this one and this one, are opposite. And since they are opposite, instead of using multiplication now, we'll do division, which is divided by what? Velocity ratio times 100%. So he has confirmed to us that that definition that we just read, it's okay. Now, so there are two formulas of efficiency that you have to take note of. The efficiency is same as mechanical advantage over velocity ratio times 100%, and efficiency is same as the workload over work effort times 100%. Now, let us use this diagram to calculate the efficiency of this machine. We'll use the two methods. First, efficiency is workload over work effort, which is equal to, so what is the workload of this machine? Workload, the load times the distance moved by the load. So be load, which is 100 newtons, times the distance, which is BC, which is 4 meters. 100 times 4 meters. Now, work moved by effort will be the effort, 200 newtons, times the distance moved by the effort from A to B, which is 2 meters. So we have 100 newtons times 4 meters divided by 200 newtons times 2 meters times 100%. You see that this one will cancel this. All of them will give you 1, and your answer will be 100%. Now, let's use the other formula. Efficiency is equal to mechanical advantage over velocity ratio times 100%. Now, first thing you have to calculate the mechanical advantage, which is load over effort. Will give you, load here is 100 newtons and effort is 200 newtons. Your answer gives 0.5. Now, velocity ratio is distance moved by effort divided by distance moved by load. So, with 2 meters divided by 4 meters, which gives you 0.5. Therefore, the efficiency now will be equal to the mechanical advantage divided by the velocity ratio times 100%, which will be equal to the 0.5, which is the mechanical advantage, divided by the 0.5, which is the velocity ratio, times 100%. Well, now, you see that this 0.5 divided by 0.5 will give you 1. So 1 times 100 will give you 100%. So that's how we calculate the efficiency of any machine.